We're now going to be looking at Sierpinsky's triangle. Now, Sierpinsky's triangle is essentially a special triangle where, well, I guess there's actually no better way than to just look at it. So I'm going to take this code in the Sierpinsky triangle py, and let's run it. So if I run it, so this is a Sierpinsky's triangle of level 1. Notice how it has, basically, there's going to be three smaller triangles with a white triangle in the middle. Now, if I want to increase Sierpinsky's triangle level 2, it basically draws this entire structure, but within a smaller triangle. So now we can see that the smaller left, right, and top triangles all have Sierpinsky's triangles inside of them. And if I go to level 3, then again, each level essentially now has a Sierpinsky's triangle inside of it. So this is another fractal problem, and it's a pretty straightforward problem as well. So if I go to the code, let's actually look at the part which draws Sierpinsky's triangle. So I have my recursive function draw Sierpinsky's triangle. Draw Sierpinsky's triangle. Now what this function does is essentially takes in an x, a y, a size, and a level. Now the level is very similar to the n which we saw in the coach snowflake. So if the level is equal to 0, that means that we want to draw the most basic Sierpinsky's triangle. We simply just draw the polygon, which is that we just basically draw the triangle. So the basic Sierpinsky's triangle is just an entire black triangle. However, if I want to draw a Sierpinsky's triangle of depth or level greater than 0, then basically what I'm going to be doing is be drawing a triangle in the same x and the same y, but with size divided by 2. So what this is going to be doing is essentially, so let me open up Sierpinsky. So basically we call the function with x, y coordinates down here, and we say that the size is the length of the entire bottom side of the triangle. So to draw a Sierpinsky's triangle this big, I basically need to first draw a Sierpinsky's triangle on x plus y, but size divided by 2, which will draw this triangle. Then I decrease my level by 1. So that'll take care of the bottom left triangle. Then I do x plus size divided by 2. So what that's going to do is essentially say x plus, so size is this entire length, so size divided by 2 will take me over here. So the x is over here and the y doesn't change. So that's going to draw this triangle. And then I say, okay, x plus size divided by 4, and then y minus some value, which will basically take me up till here. So you can work out the math for yourself, but basically when I do draw Sierpinsky's triangle, I'm going to be calling it recursively with size divided by 2 and level minus 1, and I call it on this corner, and this corner. Thus, I'll basically make Sierpinsky triangles within each of the 3 places. Then, let's say that I do a level 2. It'll then, once again, recursively, let's say I'm drawing this current small Sierpinsky triangle on the bottom left, it'll basically call it here, here, and here. As long as we keep giving it the new modified size, it'll basically say, okay, I need to draw a Sierpinsky triangle in the given location, and our recursion will handle it. Then, once we get to the base case, when level is equal to 0, we don't have to draw it deeper anymore. We just simply draw the triangle right there.